Today we are going to look at PLC ladder programming. My name is Madam Lucy Wambua, and under this topic today we are going to look at the objectives, that is defining the terminologies associated with the ladder logic programming, and also describe how a basic ladder logic program works. That is at the end of our lesson today. What do you think a ladder logic is? Yeah, anyone who has an idea? Okay, a ladder logic is a graphical PLC programming language. We normally have a number of programming languages for PLCs, but a ladder logic is the most commonly used. So it is a graphical, it uses graphs. It uses the visual to do the programming. So now we also have another term that we call the power rail. And a power rail, we normally define it as a pair of vertical lines. We are going to look at it in the next slide. So it is a pair of vertical lines in a ladder logic program, and it is the one that carries the circuit. We are going to look at that in a short while. Then we have another definition, another term that we call the ranks. So the ranks are the ones that carry the input and output of a circuit in a ladder logic program. So they are the horizontal lines with the input and the output. So now we talked about the PLC programming languages, and we said that we have quite a number of them, but the ladder logic is the most commonly used. So I don't know if you have come across other programming methods for PLC. If you have come across, maybe you can tell us another programming method that you know for a PLC. Somebody? You can unmute. Anyone who knows other programming methods for PLCs? Hello, are we together?
Yes, we are together, Lucy. I can hear you. We can get you well. Yeah.
Okay. Sometimes you can be talking alone.
No. We are together.
Okay. So we have function block diagrams. Yeah. So that is one of the programming methods. We also have the structured steps. We have the instruction list. These are types of programming methods that you can do for a PLC. But we have the sequential function charts. So we have these 4 additional programming methods, but the most commonly used is the ladder logic. And that is what you are going to look at today in this lesson. So the other programming methods, we look at them in the course of our learning. So now when we come to the operation of a ladder logic program, from what you can see on this diagram, we have now the ranks. Remember, we have defined the rank. What is a rank? You can see it on the left side, and we have the input instructions on the left side. Then we have the output instruction on the right side. Then down there, you can see the left power rail and the right power rail. So now before we move to the next one, you can see we have our input and our output. So the condition that you have to map on the PLC ladder programming, ladder program, we have the input, and the input is supposed to give you an output. So you can see for rank 0, we have, we map the input from the left, and the output is always on the right of our program. And then the program, it runs from the top to the bottom. This is to mean that the instruction that the PLC is reading, it is from rank 0 to rank 2, going downwards. So it reads from rank 0, it gives you the output, then it goes to the next instruction, that is rank 1. It reads the input, it gives you the output, then it goes to rank 2, which is the third rank, going in that sequence up to the last rank. So that is why we say that a PLC is a ladder logic. It follows a certain logic that is from up to bottom and from left to the right of each run. That is from the input and giving you an output on the right side of the diagram. So now, as we have just said that a ladder logic is a logical procedure. So in a PLC program, things or input and runs are either true or false. So that is where the logic is coming in. So our input is either true or false, and our output is either true or false. So if the proper input conditions are true, the rank becomes true and an output action occurs. When we come back here, you find that we have the input condition or the input instruction. Now, giving you a real life example of this is, it's a motor vehicle. So a motor vehicle, when you sit on the driver's seat and the ignition is on. So when the ignition is on, it means that that is an input instruction. So if the ignition is on and the seat belt for the driver is not on, let me just use that one. So when the seat belt is not on and the ignition is on and there is a driver seated on the driver's seat, those are three conditions. The driver is seated on the seat. That is condition number 1. Number 2, the ignition is on. And then the condition number 3 is the seat belt is not on. The output that it should give you is that the alarm should go on. That is why you find that when your seat belt is not on as the driver, there is an alarm on the dashboard that goes on. So you cannot go far. You have to put your seat belt on. So that is an example that I'm giving you for the input instructions, which are giving you an output of the alarm. So when you have your seat belt on and the ignition is on and you are also on the driver's seat, then the alarm is off. So those are the conditions that I'm saying that the condition can either be true or false. So a seat belt is either on or off. So it is true or false. Ignition is either on or off. And then the driver is either there or not there. So now when you come to the next point, the rank becomes true and an output action occurs. E.g., a motor turns on. If the proper input conditions are not true, the rank becomes false. So if we go back to our example, if the seat belt is not on, that is one of the condition which is not true. So the rank is not true. The rank becomes false and the alarm goes on. So that is how a ladder program works. Then we have the logic functions of a ladder logic program. So it is based on 3 logic functions. Remember, we have talked about the logic. So the first one is and, the second one is or and, exclusive or functions. So I know this one, you have learned this one in digital electronics. And if we can relate that one, the functions to our ladder logic program, you find that in this diagram, we have two switches which are in series. That is A and B. It lights a lamp. So that is an AND function. That is switch A and switch B to light our lamp. When you go to the second diagram down there, you find that the two switches are now in parallel, meaning that it is a OR function. It is either switch A or switch B that lights our lamp. So now when we transfer these functions now to our ladder logic, you find that the AND, we have the AND function, we have our two inputs connected in series to give us an output. And then we have in the OR function, we have our two input conditions which are connected in parallel to give us an output, meaning that either of the two inputs should give us an output. A good example for the two in parallel is a switch in a house that is controlled by two different, not a switch, a bulb, which is controlled by two different switches. So you can use the switch at the balcony to light us a lamp or a light in the sitting room. And also you can use another switch maybe in the corridor to control the same switch. So that is how we transfer our ladder logic program. So now, from what we have learned, I would like us to go through this video and identify the inputs and the outputs of this system here. What are the inputs for our PLC program?
Hello.
Yes.
I think it's the bottle now.
Yeah.
The input, the bottle, then once it reaches where the tap is, there's an output. Yes.
Yeah, that is a good trial. Okay, for this one, you can see that the bottle is moving. It is being moved by the conveyor belt. And when it reaches the tap, it stops. And then it is filled with some water. Then after it is filled, it is released to go to the next stage. So with that marks the end of our lesson today. Maybe we can just review what we have learned. How does a ladder logic work? We said from left to right. From the input, it is giving us an output, and also from top to the bottom.
Yes.
Yeah, so then we also looked at the logic functions that work with PLCs, and we saw 3 logic functions. And which are they?
One is OR.
Yes.
And the other one is AND.
Yes.
And exclusive OR.
Thank you. So those are the 3 guests that we have learned today. So now we have an assignment, and the assignment is to develop a ladder logic program for an automatic car washing process. So that is our assignment. I will collect the assignment in our next lesson. And that is the end of today's lesson.